हॅलो, काय नाहीत ना. आपले रामेश्वर चव्हाण सर आहेत ना. अं,
Hello, sir. Am I audible?
Yes, you're audible. I welcome you, sir. Very good afternoon.
Good afternoon, sir.
Yeah. So we are just waiting for a few minutes. So other participants will also join.
Yes.
Yeah, sure. So dear participants, our session expert, Dr. Sandeep Dahake sir has already joined us. So we are just waiting for a few more minutes so that more participants can join. Then we will start. Please wait. Okay, dear participants, so as the time is already 3, so the other participant will keep on joining in between. So as our expert has already joined us, Dr. Sandeep Dahake sir. So without wasting any time, we welcome you sir here on this platform of this second day of this year. So dear participant, before requesting Dr. Sandeep sir for his talk, I would like to request, I would like to just please mute your mic in between interruptions. Yeah, these disturbances really affect the flow process of this FDP. Yes, please. Sorry for the interruptions. Yeah, so Dr. Sandeep Dahake, the CEO and founder of Precision Private Limited, incubated at Center for Excellence, VNIT Nagpur. He has completed his bachelor degree in mechanical engineering and MTech in CAD/CAM from RTMNU. Completed his PhD and postdoctorate from VNIT Nagpur in biomedical and rapid prototyping domain. He is having more than 13 years of experience in the domain of biomedical and research. He has published 20 plus articles in the various international and national journals so far. He has also received BIREC Big Biotechnology Ignition Grant in 2019 from DBT of for rupee 50 lakh. He has received Mimics Innovation Award in 2020 from Materialize Belgium of 1,000 euro in the category from Asia Group. He has also received New Generation EIDC grant in 2021 from NST EDB DST of rupee 2,50,000 rupee. Another grant is there in Nidhi Prayas grant. He has received from IIT Bombay DST with 10 lakh. Another grant sir has received from NRDC of rupee about 90 lakh. So a lot of research grant you can see here. So how much expertise sir is having, because the research area is related to the 3D printing, CAD/CAM, 3D scanning, customized medical devices, product design and development, and so far. So there is a lot to say about Dr. Sandeep sir, but as the time limits, I'm just handing over this session to Dr. Sandeep sir. Sir, session is yours, please.
Thank you very much, sir, for this introduction. Should
Welcome,
I start the lecture?
Yeah, sir, please. You can share your screen and you can discuss with the participants.
Yes, thank you, sir. So, good afternoon to all of you. Whether my slides are visible?
Good afternoon, sir.
Yes,
sir.
Yes. Okay.
Good afternoon.
So, good afternoon. Yeah, good afternoon to all of you. Today, I am giving a talk on the topic of custom surgical guides using 3D printing. I am Dr. Sandeep Dahake. I am CEO and founder of Precision Private Limited, and my company is incubated at Center for Innovation, Vishweshwaraya National Institute of Technology, Nagpur. So, I think this is the second day of this workshop, and you might gone through the different technologies, variety of technologies related to the 3D printing. This device basically custom surgical guides because of the customization nature or patient specific. It has to fabricate by using only 3D printing technology. Which this type of devices by variety of technique, but the most suitable technique is the 3D printing. So in my presentation, I will discuss about the custom surgical guides. What are the different types of custom surgical guides? How these guides are useful in variety of surgeries. Then development of these guides and customized implants. Then I will discuss again some important case studies related to the custom surgical guides. So you might aware about the jig. What is jig? Jig is a device which helps to guide the tool. What is jig? Jig is a device which helps to guide the tool. Maybe it is a cutting tool or a drilling tool. So this custom surgical guides, it is nothing different. It is the same. It is a type of jig or it is a jig. As you are using this jig in a surgery, because of that, it is called as surgical jig. Again, we are developing it for a particular patient. So it is a patient specific device. Because of that, it is called as custom surgical guides. So the broad definition of this custom surgical guide is it is a jig designed and manufactured by an engineer. Who can design it? Only engineers or those who having the skill of designing and manufacturing, they can design and manufacture it. But the important thing is that before designing and manufacturing, it requires surgeon's input. Because who is going to use this device? Ultimately, the surgeon. You do not know the details about the surgery. So the surgeon can tell the plan, and accordingly one has to design it and manufacture it. So CAD technology is important for development, and the most important is the surgeon's input. Okay, so this is a device designed by engineer with the surgeon's input using the CAD/CAM technology, and for manufacturing it requires a rapid prototyping technology. The main objective of this particular device is to direct the tool, because it is a jig. So the main objective of this device is to direct the tool, whether it may be a drilling tool or cutting tool, whether it may be a drilling tool or cutting tool, accurately. The word is very important. Why we are using this jig? Because to direct the tool, whether it may be a drilling tool or the cutting tool, accurately, to obtain the accurate drilling or cutting which you have planned in the surgery, or this particular surgery in the virtual surgical planning. Before designing, you have to perform this step, that is virtual surgical planning, based on the input of the surgeon. So the main aim of these devices are to accurately transfer the plan of virtual surgical plan into the actual surgery. Guys, please mute your mic. So the custom surgical guides having the capability to accurately transfer your virtual surgical plan into the actual surgery. Nowadays, there are different types of advanced softwares are available. By using this different software, you can develop this type of guides. But the main problem is how to transfer this plan into the actual surgery. Designing is simple, but how to transfer this plan into the actual surgery, for that this of guides or devices plays a very vital role. Again, you can see the shape and size of these devices are totally different in different surgeries. Why it is so? This is patient specific guide, particularly designed and developed for the particular surgery. Because of that, as per the requirement, the shape and size of the device has been changed. So customized surgical guides shape and size depends on the deformity of the bone, location of the particular bone where you have to perform the drilling or cutting operation, as well as surgeon's convenience, patient's convenience. These are all parameter has to be considered while designing these customized surgical guides. Another very important thing is that basically customized surgical guides are divided into three categories. One is the drilling guide, which is useful for accurate drilling. Most of this type of guides are useful and very commonly used in the domain of dentistry for dental implantation. So this is called as the drilling guide. In many surgeries, accurate cuttings are required, maybe for tumor resection, uh, any bone cutting or any tissue cutting. So these guides are a cutting guide, basically used for the cutting purposes. And next one is the positioning guide. Positioning guides are useful to positioning guides are useful to collect the resected pieces on their particular location, to position the resected part on the particular position. For that, positioning guides are useful. But in all the three guides, two things are very common, that are what? One is the base part. One is the base part. The base part of this particular device, that is the bottom part, bottom surface, which is actually useful to fix this device onto a particular anatomy. That is the reference surface, which has actually taken from that particular bone where this device has to be placed. So this base part is common in all the types of devices. Then the guiding part. In drilling guide, you can see the particular holes. These are the guiding parts or guiding portion provided to travel the drilling tool. In the cutting guide, this cutting slots is provided, that is the guiding part in the cutting guide, which is useful to accurately travel the cutting tool. Okay, so these two parts are common in all the types of surgical guides, that is guiding part and base part in all the types of surgery. Again, these types of guides or surgical guides having the acronyms or different names, they are popular by the different names. Some are like, it is also called as custom surgical instruments, then patient specific instruments, then customized surgical guides. It also called customized surgical blocks, customized surgical jigs, customized surgical templates, or customized surgical stents. So these are the popular names of this device, custom surgical guides. Okay, so basically they having a three types: drilling guide, cutting guide, and positioning guide. How these guides has been evolved? So in previous practices, accurately transfer of virtual surgical plan into the actual surgery was the main problem, even though many advanced technologies are available. I have already discussed that there are many softwares available in the market. By using that software, designing of different devices are not a big challenge. But how to transfer this particular plan into the actual surgery, that is main problem. So for that, this type of devices are helpful. In the current practice, different computer navigation systems, then robotics surgeries, advanced robotic surgeries, and nowadays this type of RP assisted custom surgical guides playing a very important role to accurately transfer your virtual surgical plan into the actual surgery. Initially, these types of guides or customized surgical guides initially used in the dentistry for the drilling purposes only, or in the oral implantation. But gradually These techniques were used in various complex surgeries for drilling and the cutting of the bones. And nowadays, these types of surgical guides are commercially available. Initially, these types of guides has been developed by using different 3D printing techniques like stereolithography or fused deposition modeling technique or 3D printing in a polymer material like ABS, PLA or different types of plastic materials. But nowadays, different metal manufacturing or metal 3D printing technologies are available. By using that, this type of surgical guides can be developed in a metal also. So selective laser sintering, selective laser melting, direct metal laser sintering, electron beam melting. These are some technologies. By using these technologies, this type of surgical guides can be developed in the metal or biocompatible metal like titanium, stainless steel, or cobalt chromium material. RP is very useful to develop this type of surgical guides. Some people tried to develop this type of guides by using conventional machining and casting also, but rapid prototyping overtaking all the traditional technologies for the development of this type of devices because of the complex shape of this type of devices. When you developing this type of surgical guides in a metal or biocompatible metal, the advantages is that metal having a good wear resistance as compared to the plastic. So the strength of this device is high, wear resistance is good. So that is useful in the surgery because in the surgery they are using a high speed cutting tool or drilling tool. So to sustain this good resistance is important. Then good stiffness of the metal, good temperature resistance. If you are developing this type of parts in a metal, then you can develop very thin part. That is advantage in surgery. You can avoid the bulkiness of the device if you are developing in the metal. If developing in the metal, less material is required. That is again the advantage. But the main disadvantage of this metal technology is the cost of metal 3D printing. That is quite high. That is quite high. Because of that, this metal 3D printing for development of custom surgical guides are not so popular. People are nowadays developing this type of guides only by using a regular technique like stereolithography or fused deposition modeling technique in a polymer, different types of polymer. Now, another very important question is why only the rapid prototyping technique is useful for the fabrication of this type of custom surgical guides. So the answer is that this 3D printing gives very high accuracy as well as the surface finish. I have already told you two parts are very important in custom surgical guides. One is the guiding part, another is the base surface. That base surface is very useful to fix this device onto a particular anatomy. That is the reference surface. Okay, so RP give high accuracy part or high surface finish part. Because of that, this RP is the only technology for the development of this type of custom surgical guides. It gives excellent visual appearance and internal structures as well as the strength. It can create minor details such as undercuts, voids, contours, which are available on the anatomical geometry. The shape of the geometry is different person having different anatomical geometry. There may having different undercuts, voids, contours that can easily transfer on the base surface. Because of that, this development of this customized surgical guides using 3D printing plays important role. Also, nowadays, variety of materials are available in the 3D printing. Different biocompatible materials are available in 3D printing. So because of that, this custom surgical guide has to be fabricated by using rapid prototyping technology. So these are the different rapid prototyping technology by which we can fabricate this type of custom surgical guide. Many people develop this type of part by using SLA technique in different resins. Then SLS, selective laser sintering technique, in different polyamide material or nylon material. Then FDM technique, where PLA, ABS, this type of different materials are useful for development of this type of custom surgical guides. Then different 3D printing, selective laser melting, direct metal laser sintering, electron beam melting in different materials like metals, cobalt chromium, titanium material, SS316L. So these are the different techniques, rapid prototyping technique, by which this type of custom surgical guide fabrication can be possible. What is the need of this type of custom surgical guides? Why it is important to use this type of custom surgical guides into the surgery? Because this type of guides improves the accuracy of the surgery. When you using this type of drilling guide or cutting guide for exact cutting, so it helps to improve the accuracy of the surgery. Also, because of the direct fixing of this device for particular drilling or cutting, so at the time of surgery there is no need of extra measurement, extra finding of the location. This all things have to be avoided using this one device. You just have to place this device onto a particular location and you can directly perform the surgery. So it helps to reduce the surgery time. Because of directly using this device, it simplifies the surgery. No need of actual measurement into the actual surgery. Whatever the plan, whatever the measurement required into the surgery for the cutting or drilling, that data already incorporated into this particular devices, that is custom surgical guide, while the virtual surgical planning. In the part of virtual surgical planning, you have to incorporate all this plan before the manufacturing or at the time of designing of this particular surgical guide. So at the time of particular surgery, there is no need of actual measurement or finding of any location. You can directly fix this device into the surgery and use it for accurate drilling or cutting. So it helps to simplify the surgery. It reduces the operating time because of no need of extra work. You can directly fix this device, and most importantly, the device having the capability to transfer whatever you have designed, whatever you have planned virtually. The software or this particular device having the capability to accurately transfer your CAD/CAM plan or CAD/CAM technology into the operating field. Whatever you have planned virtually in virtual surgical planning, this device having the capability to transfer this particular plan into the actual surgery. So that these are the advantages of this custom surgical guides. So if you see the literature or previous work, so there are various domains where this type of custom surgical guides are useful. Maybe it is cutting guide or drilling guide. So you can see the most of the work or this type of custom surgical guides initially started using in the domain of dentistry for accurate fixation of the dental implant. Around 25% work has been completed in this particular domain as compared to the others. Then craniomaxillofacial surgery for accurate cutting of the mandibles, maxilla, then for fixation of the cranial plates. In this type of work, maybe drilling guide, cutting guide, or positioning guide, that guide, this type of custom surgical guides are useful. Then particularly patient specific implant in different surgeries like knee surgery, hip surgeries, or mandible surgeries. This type of different surgeries, this type of custom surgical cutting guide basically useful. Then total knee orthoplasty, total hip orthoplasty, this type of cutting guides are useful. Then in the neurosurgery for accurate fixation of the or finding a particular location to transfer the pacemaker uh, to activate the brain. In this particular situation, drilling guide is needed in the neurosurgery. So you can see very few work has been done in the sector of the neurosurgery. Then corrective osteotomy, uh, then metatarsophalangeal joint for twisting of the metatarso bone and assemble in a particular location, orbital implant placement, then bone tumor resection and allograft reconstruction. These are the few surgeries where this type of custom surgical guides are useful, maybe a drilling guide or the cutting guide, but maximum work has been done. Yes, any question? So maximum work has been done in the dentistry side, craniomaxillofacial size, then particular implant placement, total knee replacement, total hip replacement. This type of custom surgical guides plays very vital role, maybe a drilling guide or a cutting guide. If you see the detail about the craniomaxillofacial surgery, in the craniomaxillofacial surgery, around most of the work has been done into the tumor cutting side, accurate resection of the tumor, maybe mandibular tumor or maxillary tumors. So these types of guides playing a very vital role. Then fibula flap surgery. This is the gold standard methodology in a mandibular surgery. Instead of using any customized implant, they use a fibula bone graft in the mandibular surgery after the tumor resection. So this is very complex surgery because fibula is a straight bone and mandible is a curvy or U-shaped type bone. So in this part,
முன்னாடி போய் நீ வேகமா ஓட்ட போறியா? இல்ல வாத்தியாரே, பின்னாடி தூக்கி தூக்கி போடுங்க.
so please mute yourself. So in this type of complicated surgery for cutting of the fibula bone in a several part and then assemble it as per the requirement of the mandible, it is very complex. So in that particular case, this type of custom surgical guides playing very vital role. It reduces the surgery time, huge surgery time. Okay. Then in orthognathic surgery, around 10% work has been completed. In genioplasty is the cheek surgery, that is adjustment of the cheek. So in this particular case, this type of cutting guides are useful. Then mandibular tumor cutting and implant placement. Then cutting of the different types of graft, maybe iliac crest, then scapula. These are the different bones you can be used as a graft. So for cutting this type of particular grafts, this type of surgical guides are useful. But very few work has been done in this domain. Another very interesting surgery is the MDO surgery, that is the mandibular distraction osteogenesis surgery. This is very complicated surgery. We will see a complete detailed case study related to the mandibular distraction osteogenesis. In this particular case, basically though for fixation of the distractor, drilling guides and cutting guides are useful, and then sagittal split osteotomy. So these are the different surgeries related to the craniomaxillofacial, and most of the work has been completed into a tumor cutting, fibula flap surgery, orthognathic surgery. Some work has been done into genioplasty, but very few work has been done related to these different bone graft cutting like iliac crest, scapula, distraction surgeries. So these are the research areas where researcher can enter for the research. So these are the various type of surgeries where this type of custom surgical guides are useful. In mandibular reconstruction, basically custom surgical guides related to the cutting, or custom surgical cutting guide or osteotomy guide. Osteotomy and cutting both are similar meaning. So basically in the mandibular reconstruction, custom surgical cutting guides are useful. So you can see the complicated structure of the mandible. It having a different parts. It involves different teeth which are attached with the bone. one nerve has been passing through this mandible. This is also very important when you fix the implant. You have to place this very accurately so that there should not be any damage to this particular mandibular nerve. So in this particular thing, this type of drilling guide plays very vital role. Another important thing is you can see the structure or the shape of this particular mandible. Many time while the surgery of this type of mandible or the complicated bone, so you can see uh, this fibula flap surgery is a gold standard technique in mandibular reconstruction. What what is the technique they use in a fibula flap surgery? First of all, they have to cut the mandibular tumor. Then, by using the flap or fibula flap, which is available in your leg, tibia and fibula. So, from these two bones, fibula is important. They take this straight bone for the surgery and cut this particular bone into a number of pieces as per the requirement. They assemble it and fix it into the mandible as per the requirement. So the surgery is very complicated. You have to cut this straight bone in a such a way that you will get this particular shape of the mandible. So it requires two surgical guide. One is for the fibula cutting into accurate pieces, and another one is the accurate mandibular tumor cutting. So without this custom surgical guide for cutting this this graft accurately is very difficult. It requires lot of time to cut this particular graft and fix into the surgery. But by using the custom surgical guides, very easily you can cut this particular graft and fit into the actual surgery as per the requirement of your mandible. Then in a mandibular reconstruction, there are some associated problem uh, related to the surgery. Like while performing the cutting should be accurate, or cutting of the tumor should be accurate so that you can fix particular implant or bone accurately over there. Another important thing, if you are using this fibula preflap type surgery or any graft into a particular after removal of the tumor, then the shape and size of this particular graft should be very accurate. So accurate cutting of the tumor and the graft should be accurate. There may be chances of discrepancy between the native bone, means the original bone, and whatever the new bone you are using for the reconstruction, like reconstruction plate, reconstruction or different customized implant or any scaffold. That is called neomandible. That is the new particular implant used for the reconstruction. So there may be chances of the discrepancy. So this is very important problem. Another one is the after reconstruction, there may be chances of deformation, mandibular deformation during the normal functioning, like bending, torsion. So in surgeries, many times standard reconstruction plates are useful while performing the surgery. This type of standard reconstruction plate has to be bent and adapt onto a particular bone. So there may be chances of breaking of this particular reconstruction plate while bending. Another one is the customized reconstruction plates are also useful, but it requires a lot of time to design and development. It has to develop in a titanium material. Then manufacturing, it requires metal manufacturing for fixation, particular mandibular reconstruction. Another one is the pre-bending of the standard reconstruction plate. This is also one technique in use in the mandibular reconstruction. But in the case of pre-bending, there may be chances of improperly adoption of this particular reconstruction plate on the particular bone. There may be chances of gap between the this reconstruction plate and the bone. So again, this is a problematic. In some surgeries, surgeons uses this custom titanium tray. Again, there is a problem of manufacturing. Also, it requires some scap or some grafts for the fixation. There may be chances of discrepancies in the crowns. Whatever the crowns you use on the particular graft, there may be chances of discrepancy. So these are the persistent problems related to the mandibular reconstruction. These are the particular problems related to the mandibular reconstruction. Also, when you are using the graft, different types of graft like iliac crest, radial flap, then scapula, fibula, these are the different bones by which you can take the graft. But accurate cutting of the graft is very, very important for the to improve the aesthetic as well as the functionality of the particular bone or the mandible. But when you take the graft, it also uh, associated some important problems related to the donor side, like the if you are taking the graft from iliac crest, radial, or scapula or fibula, so there may be chances of some difficulties at the donor side also, like difficulty in restoration, then loss of function of the in the case of radial flap, loss of the function of the arm. Then if using the scapula bone, then there may be chances of the difficulties in the shoulder movement. If you using the fibula, there may be difficulties in extension and flexion of the first toe. So these are the associated problem when you are using the graft for the mandibular reconstruction. So to avoid these problems, nowadays in a recent advances, people are using a customized implants. They are using a customized implant. So this type of customized implant has to be designed at the time of surgical planning only. This type of custom implant has to be designed at the time of surgical planning only with the custom surgical guides. Both the devices has to be developed at the time of virtual surgical planning only. This is the one technique. Another technique, by using these techniques, no need of extra grafts are required. That is the advantage, means there is no any problem related to the donor side. That problem can be avoided. That is the advantage of this customized implant. Another technique is the distraction osteogenesis. So this is a one technique called as mandibular distraction osteogenesis. In this case particularly, the bone has to be resect as per the plan. Then they have to fix one device that is called distractor. It is just a nut and bolt type of arrangement. Now, once you have fixed this particular nut and bolt type arrangement called as distractor with the two different bones, related bone, now surgeon has to just rotate the or twist this particular bolt. As per the rotation, you can distract these two bones because of the nut and bolt arrangement. So there is a one technique, as per the requirement, surgeon can rotate the bolt and increase the distance between the two bone. So what happen in between the two bone? There is naturally bone formation takes place. Initially, the callus has been formed. That is the having very low strength, and gradually the strength has been increased. That is the formation of the new bone takes place in between the gap. Technology is called as the distraction osteogenesis. It is using in the mandible side, because of that it is called as the mandibular distraction osteogenesis. And the device is called as the distractor. Very famous technique, basically useful in the mandibular reconstruction surgery. Then another one is the use of the scaffolds, different type of patient specific scaffolds in biocompatible material like beta TCP. This is bone like material. So nowadays people are using for the reconstruction of this type of bone, this type of scaffolds in biocompatible material. Then different types of reconstruction, customized reconstruction trays with the scaffolds. This is another technique. So these are the different techniques which are useful in the mandibular reconstruction. But the problem is that this is the case of government dental college and hospital. They have used this type of recent custom implant for the surgery of this particular patient. So this is the case of government dental college and hospital. By using the advanced technology, they have designed a particular customized implant for this lady having a mandibular tumor, and surgeon has to resect this particular tumor first, and they have to fit this customized implant over there. So what they have did, they perform a manual surgical planning and designed a particular implant for this surgery. Now you can see in a figure D, they fix implant over there. They have initially first performed the manual surgical planning, designed the implant and fixed this particular implant at the location where they planned. But because of the manual surgical planning, they have not properly cut this bone from the required location, and the huge gap between an implant and the bone has been arises. The screws has not properly fitted, so there may be chances of loosening of the screws because of the huge gap between implant and the bone. You can see this yellow arrow and this highlighted circle. There is a huge gap between implant and the bone. Why this happen? This happen even though they have used advanced technology for designing of this particular implant, but they have not used any virtual surgical plan or custom surgical guides for the cutting of this particular tumor and the fixation of this particular implant. Because of the manual surgical planning, they were they not possible for them to accurately transfer this virtual surgical plan into the actual surgery. So that is the problem in the design particular implant. You have to transfer your virtual surgical plan into the actual surgery, and there is a need of custom surgical guide, accurate resection of the bone. Then only accurately fit this particular customized implant into the planned location. So what is the research gap? The research gap is that this type of customized surgical guides for accurate tumor resection and implant placement in ablative tumor surgery, that is the cutting of particular tumor, has not done previously in many surgeries. Then the effect of gap between implant and bone in mandibular reconstruction has not been performed. Precision of this type of custom surgical guide has not been done previously. Also, this type of custom surgical guides in various complex surgeries like mandibular distraction surgery, osteogenesis surgery, not done previously in many surgeries. So this is the research gap, the lot of research required in this domain. Now, the another important terminology is how to develop this type of custom surgical guides or customized implant. So there is a standard generalized methodology for development of this type of custom surgical guide. So initially it requires a raw data like CT scan, CBCT scan, MRI scan. So this initial data is required for designing of this particular custom devices. Maybe it is implant or surgical guide. The next step is the image processing. In image processing, whatever the data you have obtained that is available in a DICOM format, that is digital imaging and communication in medicine, There is the full form of the DICOM. These are available in DICOM format. Initially, you have to convert this DICOM format into a particular format for the 3D printing. Before that, you have to process this DICOM in a different softwares like Mimix or Geomagic D2P. These are the different softwares required for the image processing. Once you are done with the image processing, then next step is the whatever the particular data you require that obtained after image processing, then you can design a particular surgical guide or surgical or custom implant by using a different softwares like thematic or geomagic freeform. These are the different softwares useful for the designing of this type of particular devices or editing of the particular data which is available in STL format. After the image processing, data is available in STL format. So these are the different compatible software where you can design this type of customized implant and customized surgical guides. Once you have completed the designing, next step is the fabrication of this particular devices by using a different rapid prototyping technology. Like you can develop this type of custom surgical guide by using any FDM technique in polymer material and a customized implant using any metal rapid prototyping technique in a titanium, cobalt, chromium or stainless steel 316L. Then you have to perform a mock surgery, and by after mock surgery, after surgeon's input and sterilization, you can directly use this type of devices into a actual surgery. So basically this type of development of this type of custom surgical guides or custom devices has been divided into two parts. One is the first part is the virtual, which included data acquisition, image processing, virtual surgical planning, and the CAD. And the next is the development of this particular part after the designing. That is the physical, that is fabrication of this particular devices using the rapid prototyping and the post processing. So this is the generalized standard methodology for the development of this type of custom implants. If you see in detail, so this particular process has been divided into four parts. First one is the scanning. It requires a scanning, that is for the raw data collection, CT scan, CBCT scan. Then next one is the CAD, computer aided design, which included the image processing, virtual surgical planning, then design of a particular bone, then design of particular surgical guide, maybe cutting guide, drilling guide, then designing of the customized implant, and the testing of whatever you have designed like implant, the testing of this particular implant by using any finite element method or any experimental method. So this is the part of the CAD. The next part is the additive manufacturing. By using different technologies, you can develop this type of part, maybe custom surgical guides using any polymer, and customized implant by using any metal manufacturing in titanium or cobalt, chromium or in stainless steel material. Once it is done, you can directly use this type of parts after sterilization into the surgery. So these are the four important parts in the development of the custom surgical guides or custom implants, that is scanning, CAD, additive manufacturing, and then the surgery. If you see in the detail, in a virtual surgical planning, you have to decide with the surgeon's input what is the tumor size, then what is the surgical margin. Surgical margin means additional bone after the tumor. Then cutting space required, which type of cutting tool you are using, what is the thickness of this particular tool. So this plan you have to incorporate in your plan virtually. Based on this plan, you have to design a particular implant or a surgical guide. So you can see in a figure number 1, there are different parts. The first one number is showing the diseased mandible. from front view and then back view. Then point number 2 and 3, this showing the particular cutting planes. As per this virtual surgical planning, you can fix this particular cutting planes. After cutting this particular bone by using this cutting plane, you can see point number 6 and point number 7. These are very important. These are the contact surfaces. These contact surfaces are very important for the designing of the implant, because your implant is going to fix over there at the contact surfaces. So this you have to transfer this particular shape and size to the implant also. So in virtual surgical planning, this these are the important things you have to consider. Then for the designing of particular implant, you can see the shape of the particular implant is suitable to the particular bone. You can change the design. You can prepare the hole in between to avoid the weight or to reduce the weight of the implant. You can change the design. That is, I have taken here the teeth on the implant. You can remove this, and then in final implant, you can, whatever the available implants in the market, you can fix over there also. That is also possible. You can design different types of teeth separately also. That is can also be possible. But important thing is that, like in point number 12 and point number 11, these are the fixation plate of this implant, and the surface of this particular fixation plate is taken from that particular anatomy, which is very important, very important to fix this particular implant at the planned location. Another one is the point number 9 and point number 8. These are the that contact surfaces. That contact surfaces of the implant should be matches with the contact surfaces of this particular cutting bone. Then only accurate alignment of this implant can be possible, otherwise not. So these are the important features that must be included in the customized implant. Another one is the location of this screw hole. This screw hole has to be designed in such a way that after fixation of the implant, the screw should not be enter into the mandibular nerve. So that has to be finalized in a virtual surgical planning. The positioning of this particular drilling hole has to be decided based on the this particular nerve available in the mandible. That has to be done into a virtual surgical planning. Then the shape and size of the implant may be vary as per the requirement of the surgeon and the suitability of the manufacturing technology. In the case of the custom surgical guides also, you have to consider some important parameter. This is the design of one surgical guide only. I have taken the different views only to show uh, different aspects of this particular design. You can see point number 15 is the base surface. This is the point number 15, and this shows the base surface. This base surface is nothing but the surface taken from the particular anatomy, so that this particular device can be exactly fit onto the particular location of this particular anatomy. Okay, so base surface is useful for fixation of this device. That point number 16 and 17, you can see this is the 16 and 17. These are the particular cutting guides which are useful for the cutting purposes. The tool is traveling in between this particular slot. This is important in surgical cutting guide. Then 18 and 19, um, 18 and 19, this is the particular retention plate. This is the this 19 is the retention plate, that is in the plate in between this particular slot. Then another one is the point number 22. This is the positioning plate which decide the size of the tumor, which is important. Another one is the point number 24. You can see this arrangement has been provided to fix this particular device onto the particular bone. So there is a provision. You can directly snugly fit this particular device onto the bone without using any external screws over there. So again, important thing is this particular point number 27, that is the patient's ID is important. Then this L and R, that is the left side and right side, that are the indicators that should be provided on this particular device to avoid the confusion at the time of surgery. So these are the different facilities you have to provide on the surgical guide so that you can directly use this device into the actual surgery. Once you are done with the designing and virtual surgical planning, you have to virtually test or virtually do the functional testing. In the functional testing, you have to check whether this custom surgical guide has to be fit onto the particular anatomy or not. Is there any problem for fixation, any particular anatomy coming in between the surgical guide while cutting? That you can decide or you can check by fixing this particular device onto the anatomy virtually. Also, after development of the design or designing of the particular implant, you can check the size and fit of this particular implant in the particular anatomy. You can check the different views and check whether the design of implant is proper or not, or fixation or contact surfaces are properly uh, um, located at a planned location or not. Then the fixation of this fixation plate of this particular implant is on proper location or not. That is the that you can check virtually in a virtual functional testing. So before the actual surgery, this is the important step. Then next one is the once you are done with this particular designing and development, you can very easily fabricate this type of parts and perform the mock surgery by using any normal FDM technique parts or 3D printed parts. So this is the mandible, then particular implant, and this customized surgical guide. You can perform the mock surgery. You have to just pick this particular surgical guide over there. You can perform the surgery, that is the cutting of this particular implant, particular bone or the tumor. Then after cutting, you can fix this particular implant over there and check the gap between the implant. I have highlighted in red color. You can check the gap between the implant and the bone. That should be 0. If you are using custom surgical guide, the gap should be 0. You must have to get a proper and accurate fitting of the implant with the bone, so that you can test in the mock surgery. You can perform experimental analysis also. We have also done some experimental analysis. We found that the difference between the manual cutting as well as the use of custom surgical guides in mandibular cutting. So we obtained a good result with the use of custom surgical guide as compared to the without using custom surgical guide. This is the result for the anterior side cutting of the mandible, and this is the result of the posterior side of the cutting of the mandibular tumor. In both the ways, we obtained a good result. This red one showing the result of the custom surgical guide, that is the minimum gap between bone and implant, and this blue color showing the surgery gap without using custom surgical guides. So we'll see some case studies also related to the custom surgical guides. So the first case study is the related to the TMJ disorder, that is the particularly temporomandibular bone joint. Basically, this type of particular disease or this type of particular problem arises by birth also. In some accidental problem also, this type of problem in the TMJ bone, that is temporomandibular joint, has been arises. So this particular case is related to one TMJ ankylosis, the patient having a 0 mouth opening at the birth. So because of the 0 mouth opening, he facing a problem of eating, speech, oral hygiene, etc. So because of this problem, surgeon suggested a mandibular distraction osteogenesis surgery, which we have discussed in previous slides. That is the cutting of this particular bone and take it downward, then opening of this TMJ joint. These are some surgeries. So if you see the patient history, this is a particular patient having a TMJ ankylosis and 0 mouth opening. At the this problem is for this particular patient, this problem is from the birth. He had undergone tracheostomy, that is the creation of the bone for the breathing at the 6 months of the age. Doctor finalized the two surgeries. One is the TMJ surgery and other one is the cutting off this particular bone from the ramus section. This is the ramus section of the bone, cutting off this particular bone from the ramus section and take 20 mm downwards. Then cutting off this particular mandible from the body section and take towards the front side 20 mm. So by using one device called as distractor, which we have already discussed in the previous slide, but in this case two surgeries are required. One is for cutting from the ramus section. This particular thing is the ramus of the mandible. So first surgery is required is the cutting of this particular bone from the ramus section and take it downward. That is the first surgery. Second surgery required is the cutting of this bone particularly from this body section and take towards front 20 mm. That is the second surgery. And third surgery required is the opening of this TMJ joint, opening of this particular TMJ joint, which is fused. Because of this fusedness, the patient unable to open his mandible, and you can see that the case is so complicated. The mandible is totally inside the maxilla. The mandible is totally inside the maxilla. Because of that, he cannot perform his regular activities like eating, chewing, etc. So that surgeon has to cut this portion and take it downwards so that mouth opening can be possible, and then cutting off this particular bone from the TMJ section and open it so that he can perform a regular activity of the mandible. So in this case also the same procedure has been utilized, that is data collection from the CT scan, then segmentation, recent growing, that is image processing, then fabrication of the RP model, then initial surgical planning, then final virtual surgical planning. In virtual surgical planning, they decide where to place this particular distractor, how to distract, what is the distance of distraction or required length of the distraction, then fabrication of particular customized surgical guide, then functional testing of customized surgical guide, then mock surgery, and then use of this surgical guide into the actual surgery. So in virtual surgical planning, you can see that first of all, I will show you the distractor. This is the particular device called as the distractor. In initial slide, we have seen the distractor, that is the one directional distractor. This is called as the bidirectional distractor. You can see this point number A and point number D. These are the two bolts which are attached in a hinge joint, then this X, Y and Z, these are the three clamps. And which has to fix with the bone by using this six pins, 1 2 3 4 5 and 6. You have to fix this particular device by using these 6 pins. Once it is attached, and after cutting off this particular bone, when you rotate this particular bolt, suppose you rotated the bolt A, the complete assembly has been the complete assembly you can shift from their original position as per the requirement. So in this particular case, surgeon has to cut this particular bone from the ramus section, this particular point, that is PQ point. From this is the surgical cutting guide, and 1 2 3 4 5 6, this is the drilling guide. So basically this is the combination of two guide. One is the cutting guide as well as the drilling guide. For fixation of this particular pins, this drilling guide is useful, and for cutting of this particular mandible, this PQ, that is the cutting guide, is useful. So the challenge is how to fix this particular device onto a planned location. Again, this is the bilateral surgery. Bilateral surgery means using of this particular device or cutting of this particular bone from both the side of device, that is left side and right hand. So two devices has to be fixed into the surgery. One is from the left side, one is from the right side. So it is very difficult to pick this particular device at the planned location. Both the side of device has to be symmetric. All the pins should be parallel to each other. That is the requirement of the surgery. Again, this bone is very thin bone. So where to fix this particular pin should be placed on the proper location so that it can sustain into the bone. Otherwise, because of the thin bone, there may be chances of breakage of this particular bone. So all these complications can be avoided by using the virtual surgical planning and use of the custom surgical guides. So in this particular case, we have performed the virtual surgical planning to design the custom surgical guides, which is the combination of the two guide, drilling guide and the cutting guide. Based on this virtual surgical plan, you can see the thickness of the particular bone, and based on the nerve passing through the bone, we have finalized the location of the pins based on the cutting of the ramus section. I have highlighted in the cutting by using the cutting plane, this red color one. We have positioned the cutting location, and based on this data, we have designed a final surgical guide for the left side as well as the right side. You can see the plan. This is the pin location 1, 2, 3, 4, 5 and 6, and then green showing in PQ. This is the cutting plane. Based on this plan, we have developed designed this type of custom surgical guide, combination of two guide, drilling guide as well as the cutting guide. And finally, manufacture this guide by using a regular FDM technique. Then this is the front view and this is the bottom view. You can see the base surface which has taken directly from the mandible surface, so that this device can be fixed exactly on the planned location. Then we perform the mock surgery, fabricated the part by using FDM technique, then check by fixing the device on a particular location, then fixation of the pins as per the plan. Based on this pin, fix the extraoral distractor at the planned location. Now you can see that the fixation of both the devices, that is both the extraoral distraction instrument on both the side, that is left side as well as the right side, which is possible exactly because of this custom surgical guides. Otherwise, it is very difficult to fix this type of distractor at the planned location in this type of complex surgeries. Then we use this particular device into the surgery and fix this particular device into the surgery by using the custom surgical guide. Then perform the cutting operation and then process the distraction. So these are the surgical outcomes. These are the photographs after fixation of this device into the patient's mouth or in the patient's mandible by using the custom surgical guides. And these are the results after the surgery. Once fixation is done, then perform the cutting operation and the rotation of this particular bolt, that is the first bolt, vertical bolt, daily 1 mm. So accordingly, by daily 1 mm, 20 days they have rotated the particular bone and develop the distance of around 20 mm in the ramus section. You can see the arrows in this particular X-ray. So by rotating the bolt A daily by 1 mm, they have developed a distance or gap in between the two bone is around 20 mm. That means they have shifted the bone 20 mm down using the distractor, and the distraction has been done properly. It is only possible by fixation of this particular device exactly on a planned location, and for that custom surgical guide plays an important role in such type of surgery. Now, is the advantage of this particular use of this custom surgical guides in this type of complex surgeries is achieved proper alignment and parallelism of the extraoral distractors and the vector of the distraction. That is the one advantage. Another one is the accurate location of extraoral distraction and osteotomy site was achieved. Accurately transferred the virtual surgical plan into the actual surgery. That is the advantage of custom surgical guide. And most importantly, it has reduced the operation time. Around 30 minutes to 60 minutes time has been reduced in this type of complex surgeries by using the custom surgical guides. Another case study, this is again the case of distraction. You can see the mandible is totally inside the maxilla. That particular, but TMJ joint is perfectly all right. Here there is no problem of the TMJ. So in this particular case, in previous case, surgical guide has been used only for the first surgery, that is the cutting from the ramus, and then next two surgeries they have not used any custom surgical guide. In this particular case, their TMJ joint is perfectly all right, but the problem is that you can see the mandible is totally inside the maxilla, means there is no direct connection with the maxillary teeth and the mandibular teeth. So patient facing the problem of normal eating and the chewing. So in this case, they have decided to cut this particular mandibular bone from his center. Center is called as the symphysial, and beside the symphysial, from somewhere here adjacent to the symphysial, that particular portion is called as the parasymphysial. So surgeon has decided to cut this particular bone for the parasymphysial and attach the distractor, and with the distraction surgery they can increase the gap so that mandibular teeth and the maxillary teeth matching to each other. So that is the plan of the surgery. So in this particular surgery, you can see this is the available teeth, patient's teeth. You can see initially they decided to plan. This is the plan A. They have decided to cut this particular bone from this center. If they cut from the center, they have to sacrifice these two teeth, do middle teeth. Then second plan is plan B. They can cut this particular bone from this particular arrow. If they selected this particular portion in this plan B, they have to sacrifice three teeth, 1, 2, and 3. So, and in plan C, there is one gap between the two particular tooth. So they utilize the plan C where the gap of around 2 mm is available. So they use this gap. In this particular situation, they have to only sacrifice this only one teeth. So they finalize the plan C. This is possible only because of the virtual surgical planning, and based on this plan, we have developed the surgical guide for the cutting of this mandible by using this plan C. So you can see this is the final design of this surgical guide, surgical cutting guide. Now you can see this is the front view and this is the back view. Only one tooth has to be sacrificed by using this plan. So we have finalized and designed the surgical guide. Then develop this custom surgical guide for the cutting, and then perform the mock surgery. In the mock surgery, you can see we have used the surgical guide there, perform the cutting operation using the surgical guide. Then after partially cutting of this particular bone, we have fixed this type of particular distractor, and then taken a complete cut. After complete cut, perform the operation of the distraction, that is the rotation of this particular bolt, and increase the distance between the two bones. So in such a way that the mandibular teeth has been matches with the maxillary teeth. That is accurately possible by using this custom surgical guides. So the main aim is to provide the accurate cutting in this case and fixation of the particular device over there, so that accurate distraction can be possible and the teeth of the maxillary and the mandible matches with each other. So that is the advantage of custom surgical guide. In another case study, This is again related to the cutting of the particular tumor. You can see this whole type of structure. This is nothing but the mandibular tumor, and surgeon want to cut this particular bone in the shape of rectangle. In the shape of rectangle from this mandible. So based on this particular input from the surgeon, we have designed this type of surgical guide where the provision of rectangular cut has been provided so that accurately they can cut this particular portion of the bone or particular tumorous portion from the mandible. These are the photographs of the surgery. The bone exposure is very important for the fixation of the surgical guide, because what happened while designing the surgical guide, we are using this particular surface or the base surface of the surgical guide. You can see here, this is the bottom view of this particular surgical guide. This is the base surface, and that base surface obtained from this particular bone. We have taken the reference of this bone and transfer this surface from actual bone to the device so that this can accurately fit at the planned location. So this is the cutting and exposure of the bone. The fixation of the particular device at the planned location or the cutting of this particular tumor from the bone. Then with this plan, at the time of surgery, surgeon need not have to take any measurement, any type of particular planning at the time of surgery. They just have to fit this particular custom surgical guide at the planned location without using any external screws. Just snugly fit this particular device over there and perform the cutting operation. So they perform the cutting operation. After cutting very accurately, they have resected the particular tumor from the bone and obtain this particular slot after cutting. We have prepared a scaffold by using beta TCP material. This is again a custom scaffold which is exactly suitable for this particular patient. So this beta TCP graft exactly fitted at the planned location after cutting of the tumor. We have fixed this into the particular patient's mandible. So it helps to accurately cut the particular bone and fixation of the custom scaffold. The conclusion of this particular device or particular study is that the overall this custom surgical guides helps to reduce the surgery time. It improves the accuracy of the surgery. In mandibular distraction osteogenesis, it helps to accurately fix the extraoral device. It helps to accurately cutting this particular ramus section. The mandibular distraction osteogenesis surgery was complicated. In such types of surgeries, it helps to reduce the surgery time and improve the accuracy of the surgery. And most importantly, this device is capable to transfer your virtual surgical plan into the actual surgery. That is the advantage of the surgery. But the problem is that there is no any specific direction to design and development of this type of custom surgical guide. There are different ways people are using different ways, different types of virtual surgical planning, CAD technologies, rapid technology. There is no any sophisticated way to design and development. There is a bias in the designing and fabrication process. No study has been done with the use of custom surgical guide and without using custom surgical guide. So these are the future scope, and researcher can involve in this domain for the research related to the custom surgical guides. So this is my details, and thank you for listening this presentation. Thank you. If you're having any doubts, question, you can ask.
Yeah. Thank you so much, sir, for this wonderful, insightful discussion with our participants. We are highly thankful to you, sir.
Hello.
Yeah, dear participant, if any queries are there, so you can directly interact with the Dr. Sandeep, sir, for case of any query. or you can write in the chat box so that we can ask.
Yes, sir. Got one question for Kuldeep, sir.
Hello, sir.
Hello,
Yeah.
sir. My
I am
query
Dr. Manish, Assistant Professor in CPT Jaipur. Sir, is there in a stand as you have shown their customized tool CSG? Is there a standard available for making such tools?
No. There is no standard available, but many previous literature, ISO 1101 has been provided. These are the basically standard to check the flatness, parallelism, and the location after cutting. So you can refer this, but there is for development of this type of devices, no standards are available.
No, because in additive manufacturing earlier, because in simple additive manufacturing, there was no earlier standard, but now ASM has started making the standard for AM products, AM technology
Mhm.
in metal, regarding metal parts.
Okay. So same standards can be applicable here also. Those standards are available for the rapid prototyping that can be used for manufacturing of this type of parts also. But no any separate guidelines for the development design of this type of custom surgical guides are available.
There one more, sir, my request, sir, to please share the slide with all the participants in form of PDF.
Yeah, definitely,
Okay.
Dr. Manish, sir. It is live on YouTube, and for your record
No,
purpose
sir,
only we are
video
doing
sir,
that.
I'm asking adding the slides, sir, in form of PDF, not directly PPT.
Yeah, that is fine, sir. But if it is available to sir with sir, so if you wish to, then it will be shared. Okay, because it is there, because a lot of work are there, so it is confidential also. So it is very tough for our experts also. So if possible, if we will receive, definitely we will share. Don't worry about that.
Thank you, sir. Thank you, sir.
Thank you.
Yeah, so one query is there, which material we can take for guide manufacturing?
So normally, sir, people are using different FDM techniques or DLP techniques, stereolithography technique for the development of this type of surgical guide. So different types of polymers are available in the market. Nowadays, different biocompatible polymers are also available, but the cost of these biocompatible polymers are high. So as per the standard or as per the regulatory approval, you have to use the biocompatible material only, because this particular device going inside the body, even though for limited time, but they touches to the blood. So in this case, because of the regulatory rules, you have to use a biocompatible material. Any type of biocompatible polymer you can use for fabrication of this type of material. Even though you can use a metallic technique for development of this type of surgical guides, but because of the cost of the metal 3D printer is very high, you cannot go with this. But if possible, you can afford, you can develop this type of parts in metal also by using metal 3D printing in titanium, cobalt, chromium, or stainless steel material. Yes. Any other question?
So what I feel, sir, I think a lot of queries in between you have already responded, and now we have discussed about this query success. Yeah, so our participant is asking about success rate of surgeries according to research papers.
According to research paper, we have already performed the finite element analysis of to compare the results of the surgeries with guide and without guide. Also, we have performed the experimental analysis, which we have not shown. In that, we found that custom surgical guides gives accuracy around 90 to 95%, or even more than that. Okay, but again, it is depend on what? It is depend on the material you are using for the development of the custom surgical guide, because you are using a polymer material and use it into the surgery. So surgeons are using a high speed tool, that are cutting tools or drilling tool. Many times while cutting the particular tumor or while performing the drilling, that surgical guide itself cut and hamper the accuracy of the surgery. To avoid it, you can fix a metallic sleeve in between the cutting guide or in the cutting slot or in the drilling slot, which helps to improve the accuracy of the surgery. If you are using the metallic sleeve in the guiding portion, then you can improve the that particular accuracy up to the 99% also. That is the possibility. Again,
Kindly tell some composite material used for jaw or dental surgery.
In dental surgeries, particularly for development of custom surgical guide, there are different materials like different brands. Nextent is one brand. Then different form labs material are available. For development of particular castable materials are available in the form lab. For development of particular custom surgical guides, specific material for development of the custom surgical guides are available. So you can use that material for development of the custom surgical guides.
So can we use metallic screw in polymeric implant?
Polymeric implant. First thing is that you cannot use the polymeric implant. Polymeric implant means if you are using a PEEK material, polyether ether ketone material, in that particular implant you can use the screws also. But again, it is depend on the what thickness you are taking. If you are taking the thickness of fixation plate is around 2 mm, so there may be chances of the breakage of this particular implant, polymeric implant. If you are increasing the thickness of the polymeric implant, that is difficult as per as your surgical point of view or as per as the aesthetic and functionality point of view. So, but you can definitely use the stainless steel screw or metallic screw.
Okay, thank you so much, Sandeep sir. I think a lot of queries has already been considered now. So we are highly thankful for your valuable time, sir. We are delighted to have you here, and thank you for your kind support and valuable information. Thank you.
Thank you, sir. Thank you, sir. Thank you, all the participants. If you having any query, you can directly contact
Yeah,
me.
definitely.
Or
We are also, so there is another session of yours. So definitely participant can ask the queries there also. No issue.
Yeah.
Yeah.
Okay.
Yeah.
Thank you.
Okay,
Thank
sir.
you all.
Thank you so much. Thanks a lot.
Thank you.
So dear participants, here we are compiling the second day of this ATAL FDP program. Okay, all the attendance links and all already been shared in the chat box of YouTube as well as the WebEx platform in the WhatsApp group as well. So just go through and mark your presence there. And we will see you tomorrow, sharp 11:30 for another
No,
session.
morning session link I haven't received actually, sir, for attendance. Morning session link.
Okay, I will see because we have a lot of time we have shared. If particularly you have not filled, then I can see. Okay, no issue. Okay.
Thank you, sir.
Okay.